to do what next, Avery?
Subtract 11 from each side.
Why do you think that? Not saying it's wrong. What was your thinking behind that choice?
Because it was the reverse prime dash.
Very good.
You do actually the second thing, which would be the plus 11.
Very good. Undo plus 11 by subtracting 11 from each side. Very good. Negative 7 minus 11. That's where this is going to get the trickiest, is when you have these different signs. Nice job, Bridget and Ellison Button as well. What am I going to get?
You're going to get negative 18.
Good, because a negative plus another negative is like you add them, or minus a number, negative minus a number, is like you add the two numbers together and then they're negative. Good. Negative 18 is equal to how much? What do we get, Lily? Negative 18 is equal to?
9x.
Very good. Yes, nice job, Lily. 9x. Okay. So now, I'm here. I need to get a single x. How is that x attached to our 9? Olivia.
It's attached by multiplication, so you have to do division.
Very good. Nice job, Bridget, on that one as well. It's attached to multiplication, so we undo it by dividing by 9 on each side. So then, Carter, what am I going to get when I divide negative 18 divided by 9? Nice job, Bridget.
You get 2.
What kind of 2?
2x.
So x is equal to what kind of 2? Negative 18 divided by 9.
Negative 2.
A negative 2. Very good. Whoop. Very, very, very good. Fantastic. I'm going to leave that up for a moment. We're going to think about our learning targets for today. You guys don't have these written in your packets. That's okay. We're going to look at them up here together. My friends at home, you don't need to write anything on your slides when we go to this slide. We're going to just look at it together. So I'm going to skip-a-roo down to the next piece of this. Let's take a look at slide number 3. Slide number 3 has our 2 learning targets for today. And you're probably looking at this and you're like, Mr. Jermaine, you hit enter way too many times. I did, on purpose. So we're talking about our ICANN for today. One of them is being determining the number of solutions an equation has. So when I ask you, how many solutions does this equation have? You have 3 possible answers that you could give. What's one possible number of solutions you could have?
No solution.
No solutions. Good. Annie, what's another one that we've been talking about? So we could say it has no solutions. How many? Yes, infinite or many solutions. Yes, very good. Infinitely many solutions. Very good, Annie. Fantastic job. Last possible combination, just like Jada Ramos said, Avery.
1 solution.
1 solution. Very good. 1 solution was the one that we really introduced and focused on yesterday. Very good. 1 solution. Okay, so those are our 3 options for determining the type of solution it has. Then we're going to be able to solve some multi-step equations. That means we're doing a couple things to this equation to get the x by itself. Okay, nice job on that one, guys. Let's take a look at the quick little review of our notes from yesterday. So we were talking about no solution and infinitely many solutions for the last couple days. Yesterday, we took this note sheet and we added on this concept of 1 solution, okay? With no solutions, we look at it. When we look at our equations, we're going to say, when we look at our equation, we're going to say no number that I plug in there is going to make it true. So that means our variables, our x values are the same on both sides, but the constants, the numbers by themselves, are different. Then we look at this idea, this concept of infinitely many solutions. Hey, Billy.
Oh,
Here you are. You need pencil?
I got it.
Oh, perfect. You know if you need a sharpener. Okay. Then we're talking about this idea, this concept of infinitely many solutions, which when we look at it, it means that no number, or you can plug any number into that equation and it would be true. That means when you're looking at it in the equation itself, it's going to have the same variables on each side and the same constants. The variables are the same, the constants are the same. Nice job. Last one here is this idea, this concept of one solution. There is only one number that you can plug into that equation to make it true. Remembering that when we look at it, our x values or our variables are different. So you can say, yes, because our x values and our constants are different, like if that happens to be the case. But the really important piece is when you look at it, if the variables are different, you could automatically say it has one solution. Because if you look at this first example here, I have 7x plus 2 is equal to 6x plus 2. Our constants are the same, but the piece that makes it have only one solution is the fact that the variables are different. I want to make sure that that's really, really, really clear, okay? Does that make sense, guys? So they might have the same constants, they might have different constants, but the piece that makes it one solution is the different variables. Okay, so now we're getting into the good stuff. We're starting off with some easier pieces to this. We're looking in our packet. If you're in the packet, you're on like the back side of the first page. Letter A tells us that we need to, or well, this section here, it says determine how many solutions each equation has. All right, we could say one solution. We could say no solution. Or we could say infinitely many solutions. I want you to look at these three equations here and determine how many solutions each one of these is going to have. I'm going to give you 2 minutes to independently do this right now. Once you're at home, if you get answers, you can say A is, B is, C is. Let me know. This guy was supposed to be pretty easy. That's not quite. Nice job, Bridget. Wonderful job. We have about 1 more minute, guys. Nice job, Bridget.
It's in the order.
Hmm?
It's in the order.
Oh, really? Oh, that's so awkward. Totally unintentional. Awesome, awesome. Taking another 45. We got this, guys. Nice job. Oh, that's so weird. I want to get some answers from people at home. Nice job, Kaylee B. Olivia, Avery, Billy. Bella. Perfect. We're missing 3 friends today. Okay, let's come back together. Okay, we are looking at letter A. I have a lot of friends that are at home saying that they think Let's see. One has one, or A has one solution. So what do you guys think about letter A here? How many solutions is letter A gonna have? Avery, why do you think? Avery is saying she thinks it's gonna have one solution. And why do we think that letter A is only gonna have one solution? What made you think that looking at it? Well, let's see what Bridget said. Bridget said A has one solution because the variables are different. What were you thinking, Avery?
Well, I was thinking because there's like an x on each side of the equal sign that you would have to, put x on one side and in the end maybe get one solution.
Get one solution, exactly. Because we have different x's on each side, that's going to tell us that we're going to have to keep going to find that one solution for the equation. Nice job, Avery. That's a good way of thinking about it. Because our variables are different here, we're going to see that this guy has one solution. What are we thinking about for B? Looking at B. Annie, what did you think about for B? She said no solution. Carter, what were you thinking for B?
I was thinking no solution.
Okay. Avery, what were you thinking for B?
No solution.
Okay. Lily, what were you thinking?
No solution.
Oh, you were also thinking no solution. Okay. So, can I have, looking at this guy here, what do we notice? Like, Carter, what were you thinking? What made you think no solution?
Because if you look at it, this is 5x minus 5 equals 5x.
Very good. So, they're not the same. So, it can't be infinitely many solutions. And we notice that the variables are what? The same, right, Billy? Nice job. The variables are the same, so it's going to be either infinitely many or no solutions. But it can't be infinitely many because I have a minus 5 on one side and I don't have that same amount on the other side. So it's not going to be infinitely many. So it's got to be no solutions. Let's think about what can we add to this equation? Avery.
I wasn't like thinking of the adding, but I think I know why it would be no solution.
Okay, go ahead. Why do you think so?
Because you would have to add the 5x on both sides. Well, you have to add 5x to one side, but there isn't really, they're both the same variable, so they would probably cancel out and you get 5.
Yep, and you would get negative 5 is equal to, remembering that, nice job, Bridget, on this side. Bridget said that when we look at the right side here, because there's no constant written in there, that means the same thing as 5x plus 0, okay? When we don't have a constant in an equation, it's like saying plus 0. So then now we can look at this and compare and say we have the same variables here, 5x, but we have different constants of negative 5 and 0. Like Avery said, if we subtract 5x from each side, they would cancel out on both sides and we get negative 5 is equal to 0. And that's never, ever, ever going to be true. So it's going to have no solutions. Couple different explanations as to why. Nice job. Now we're looking at the last one. Let me move the chit chat a little bit so we can see it. What are we thinking about for that last one here? Oh, no, that's not what I want. No, Mr. Main, you stink. Okay, so what are we thinking about for the type of solution for the last one? Avery, what are you thinking? Infinitely many, you said?
Mm-hmm.
Why do you think that?
Because both of the constants are the exact same. They're the same numbers on each of the equal signs, just in different order.
Very good. So our variables are the same, negative 11x, and our constants are the same, negative 7. So we're going to say this guy has infinitely many solutions. Nice job. We're solving here. Let's take a look at number 6. Okay? I need to get my x by itself. What do we notice about this equation here? Avery?
It's a fraction. It has a fraction.
Fraction. Very good. We have a fraction there. Billy, what else?
It equals 0.
It equals 0. Good. So if we're thinking I have x's only on one side, so I need to use reverse PEMDAS to get that x by itself. So what am I going to do first to each side? Avery?
I thought you would flip the x and the 2.
No, that's if you had like an x times 1/4. When it's attached to multiplication. That's when you would use your reciprocal. But this one is like saying x divided by 2. So we need to use our reverse PEMDAS before we can do anything with this guy. We have to undo what first, Avery?
Plus 5.
And how would we undo that plus 5? Billy?
Subtract 5.
Very good. We're going to subtract 5 from each side. On your piece of paper, you're writing this down. Cancels out our 5s here. We're left with x over 2 is equal to what? Okay?
Negative 5.
-5. Very good. And I'm done. Woo!
I love what you guys do.
Okay. Olivia, what do I have to do?
We have to multiply now.
Okay, I have to multiply to undo what?
To undo the x over 2.
Very good, because remember, x over 2 is a fraction, which means it's division. So to undo that, I have to multiply each side by 2. I'm going to cancel out my 2's there. I'm going to be left with an x is equal to, Avery?
Negative 10.
-10. Very good. Nice job, Bridget. Hey, this guy looks scary. He's a lot. So, my question to you, we're looking at this guy here. He's got a lot going on. What do we think our first move is going to have to be here? Olivia.
You could add the 3, the -3
To
both sides.
both sides?
Yep.
Okay, so we could get rid of that, I guess. We could do that, yes. We could add 3 to each side. We'd be left with 30, right? Plus 30. And then we'd still have these parentheses here. 3 times 4x plus 2 is equal to 4 parentheses 5x plus 1.
Wouldn't that part only work if it was like the exact same constant or variable in each time?
Huh?
Wouldn't that work out if it was like a -3 and a -3 on each side?
It would cancel them out, but we can do that to sort of simplify the left side. So it works. Good, Billy.
You have to, I forgot what it was called, but you take 3 and multiply by 4, and then 3 multiplied by 2, and then you have to do it on the other side.
Very good. So we would distribute. Very good. We're going to do this one together. 3 times 4x is 12x. And then 3 times a positive 2 is 6. A positive 6 is equal to 4 times 5x is 20x. Very good. 20x
Plus 4.
plus 4.
No, plus 5.
Well, no, plus 4 because it's
Oh, yeah.
multiplied. 4 times
Oh, why am I not in
is plus 4 plus 30. Okay. So on my right side, my left side, I have 12x plus 6 is equal to 20x plus what? What's it going to be?
20x plus 4.
4 plus 30.
Oh,
Can't forget about that 30.
what?
plus 4?
We added 3 to each side,
Yeah.
and it didn't cancel out the 27. We added them together. 27 plus 3 is 30. So then we have that plus 30. So it's going to be 20x plus what? 20x plus 4 plus 30
34.
is 34. I'm gonna rewrite that because I don't like it. 20x plus 34. Okay, now I gotta get my x by itself. What do I have to do here? Billy,
When you subtract 12x and 20x,
and why did you subtract the 12x?
if you subtract the 12x, it'll get you 0, so you'll just have
Good, and the 12x is the smaller of the two. So we're gonna subtract 12x, 12x, subtract 12x. We're gonna be left with 6 is equal to Avery,
8x.
8x plus 34. Good? Now I need to get my x by itself, so I need to move that constant. How am I going to move that constant? What do you think, Billy?
Divide.
We're not going to divide yet because we need to move the constant first. We undo this 8 after. We have to move this 34 first. So how do I move that 34?
Subtract.
Very good. Subtract 34 from each side. 6 minus 34 gets me Olivia?
-28.
-28. Okay? Now, Lily, I have -28 is equal to 8x. I need a single x, so I need to undo what here?
Multiplication.
By doing what? Very good. Divide by 8. Divide by 8. We're going to get an x is equal to, we can write it two ways. First, go ahead.
Me.
Yep, go ahead, Avery.
-3.5.
-3.5. -3.5, or you could leave it as this fraction. I'm just going to say, I'm going to circle them both, and I'm going to say or, because both of those are appropriate responses. The way that you would type this, let me show you, is a -28 and then the little slash, and then you would write the 8. Question, Olivia.
I did it a different way.
How did you do it?
The same answer. I subtracted 6 from each side instead of 34.
Okay. That works. Still get you the same answer. And then you would move, and then you moved your 20x over to the other side. Okay. That's still going to get you the same answer. And both of those, the thing you want to remember is you want to maintain equity. So if you're doing moves that maintain equity, doing one thing to one side that you're doing to the other side, you're still going to get to that same answer. Okay? All you want to do is maintain your equity. Okay? Let's get these steps written down for ourselves. We're going to take a look at the next piece of this. Whew. I'm going to erase just the first one. I'm going to leave that one up for another minute. Okay? So, the next piece on slide number 7. If you're in your packet, you're looking at, you're going to pancake it, I believe, because you're inside. You're going to pancake it, and we're going to look at another set of problems where we have to determine the number of solutions. Okay? So you're writing this down for yourself because you need it, and you're going to put it in here. We're looking at slide number 7 now. Tapped a little bit too hard there. We're going to look at letter A. I'm going to leave all this up here for another 20 seconds. We're going to look at A. So if I look at A, equation A here, can I make a decision about the number of solutions with how it's written right now? Looking at letter A, can I make a decision about the number of solutions without doing any work?
You could,
But would it be an accurate, but do I have a something x plus something is equal to something x plus something?
No.
No. I have parentheses. And I have something that I need to do to sort of simplify it before I make a decision about the equation. Because when you make a decision, when you're determining the number of solutions, it has to look like some number x plus a constant is equal to some number x plus a constant. There can't be any parentheses. There can't be any like division like we have here. So we have to do a little bit of work first. Okay? So as we look at this guy here, what can we do here to this equation? Billy, what are you thinking?
Distribute.
Very good. Billy says that we're going to have to distribute here. And distribute is a fancy way of saying do what? Operation. Multiply. Right? So if I were to distribute here, I want you to take 30 seconds on your papers at home as well to distribute for yourself. I'm using that as just the timer for myself. Okay? Take another 10 seconds for ourselves to distribute. When we distribute here, what do we notice about, what are we going to get for our x's here? -4 times -2x gets me, Olivia?
8x plus -4.
8x plus -4. Good. Very good. Why did you say it was a plus? Why did you say like it was a positive 8x?
Because if you multiply two negatives, it like cancels out because of positive.
Yes, Olivia. That's exactly the question, the answer I was looking for. Very good. So if we have this equation here now, I have 8x plus 9 is equal to 8x minus plus -4. What kind of solution is this guy going to have, Carter?
No solution.
You said no solution? Why do you think that? Because what has to be, what, I know that you saw that, so but what is your reason why? No solution because, what do we notice about each side?
They both have different numbers.
Man, not specific enough. They have different, those aren't just numbers, those are called what?
Constants.
Constants. Very good. Nice job. Was that Sawyer?
Yes, he stole it from me.
That was definitely Sawyer.
I did not. You said first.
Very good. Very good. I like it. You're helping friends out. I love it. We have a constant of a 9 and we have a constant of a -4. What else has to be the same for it to be no, or what else do we have to notice about it for it to be no solutions? Billy. So the constants are different, but what else, but what's the same?
The variables.
Our variables. Very good. We have the same variable of an 8x on both sides. So it's going to be no solutions or infinitely many. And then we need to look at those constants. They're different. Boom. Now we look at B here. There are two ways that we can tangle with this guy. Looking at B, I want you to think about everything that we've talked about and think, what might you do to sort of get it to be a something x plus something is equal to something x plus something without the fraction? What might you do with this? Take 30 seconds to think. I'm just going to rewrite it down below. Okay, nice job, Bridget. I like that thought. What do you guys at home think you might have to do with this? First step. There's two possible moves. Two possible moves. Okay. Bridget said break it into, she said, divide the 16x by 4 and divide the 4 by 4. That's what Bridget said. Is there a different way that you guys were thinking we might go about solving this or getting rid of that denominator of 4? What's another way that we can go about getting rid of a denominator of 4? Billy? Yes, you would multiply by 4. Very good, Billy. Yes. So another way that we could go about doing this is I want to show you. I know it's a good one, right? Isn't that a good way to do it? I'm gonna follow Bridget's way through, and then we're gonna do Billy's way. Okay? So because Caleb, you said that she liked that way, so we're gonna try to do it Bridget's way. So what Bridget did was, let me show you what Bridget did. Bridget broke this into each piece in that numerator divided by that denominator. So then if we do 16x divided by 4, 16 divided by 4 is, hi, this is Mr. Mean. Yes. Perfect, yep, no problem. Carter, you're going to Miss Jackson's office? Guidance? Oh, okay. 16 divided by 4 is, Avery? 4x. Okay, plus, how much? Avery? 1. 4 divided by 4 is 1. And then we set it equal to the other side, 4x plus 1. And then we can compare them and get a solution of what? How many solutions is this guy going to have? Look. Lily, how many solutions? Nice job, Kaylee B. Nice job, Bridget. How many? Very good. Infinitely many. Because our variables are the same, and so are our constants. Okay? Last piece we can look at with this is we could have actually multiplied by 4. And then let me show you what that would have looked like if we had done with what Billy had said. We would have multiplied by 4. Let me just go ahead. Multiply by 4. Multiply by 4. Putting it into parentheses. Canceling out. 16x plus 4 is equal to 4 times x is 16x. 4 times 1 is plus 4. Even though it's larger, you see how it got larger? Both of the variables are still the same. Both of the constants are still the same. You maintained equity, you just did a different operation. Okay? Now, last one here. What do we have to do to see here? Solve this gap.
Break the marker.
Avery,
Time to distribute on the right side.
distribute on the right side. Okay, good. Okay? I'm going to be left with 10x plus 4 is equal to, Annie, what am I going to get when I distribute here? What am I going to multiply first? So okay, so Annie, watch. So we brought this, we didn't do anything with the left side, so I rewrote it down here. Then on the right side, I needed to distribute 3 times negative 2x, 3 times negative 9. What is 3 times 2x going to get me? How many x's? How many? What kind of 6 though? It's a positive times a negative is a negative 6x. Very good, Annie. A negative 6x. 3 times negative 9 is 3 times negative 9. A negative 27. So it would be 6x minus 27. Okay, so I'm comparing. Isabella, what kind of solution would this guy have? I have a 10, let me read it to you. 10x plus 4 is equal to 6x, negative 6x, minus 27. How many?
No solution.
One more time.
No solution.
No solutions. She says no solutions. No solutions. Okay, thank you for that, Isabella. What are we thinking?
I'm trying to do it on stupid regular.
Agree or well, no, you don't need to do any work. You don't need to go any further than this. You look at your variables, you look at your constants. What do we notice about our variables? They're different. So automatically, how many solutions is it going to have? No solution. Same variable, different constant. This is not going to have no solution because we don't have the same variable. No solution only happens when we have the same variable. This isn't going to be no solutions because we have a variable of 10x. We have a variable of 10x and a variable of negative 6x. So how many solutions, if we have different variables, how many solutions does that mean we have? Avery, one solution. Not no solutions, one solution. We want to make sure that we remember those rules of when we have different variables, automatically you say it has one solution. Then if it has the same variables, you need to look at the number of constants. Are they the same? Are they different? And then you make a decision. Okay? Awesome, awesome job today. What we're going to do, what we're going to finish with today, we still have 7 minutes. We're going to look at some more solving, guys. Actually, I want to ask your opinion. Okay, this is where your opinion comes in. This is where you tell me what you want to work on more. Okay, we have 2 options. We can do some more solving, which I think you guys are good with, or we can do some equations and we need to write the other half to see how many solutions it's going to have. What do you want more practice with? Number of solutions or solving? Billy, what are you thinking?
I think number.
Yes, go ahead, Diego.
Number of solutions.
Number of solutions? Okay. That's a good choice. Last time, our friends down in Miss Lynn Johnson's room, they said, hey, we need a little bit more practice with solving. Like, we got this solution type thing. We really need more help with this solving. So you know what? We're making decisions based on what we think we need help with, okay? So it says complete each equation so that it has the indicated number of solutions. The first one needs to have no solutions. So before I can write the right side of my equation, what should I do? What do I have to do with my left side? Billy?
Don't you have to solve it out, like if it is completely full, but just on the left side?
Very good. We have to figure out what's our left side gonna like simplify to. Good. And we would have to do what operation or move to get that simplified? Billy?
You have to multiply 5 by 2x and 5 by 2.
Very good. And that's called distributing. Very good. Very good, Bridget. Nice job. So when I distribute here, 5 times 2x is going to get me what? Actually, wait, I'm going to give you 20 seconds to solve this. I'm sorry. Gotta slow down. Nice job, Bridget. That's a good thing we want to remember. Ooh, nice job. Bridget already gives us an idea. Okay, so when we distribute, we're going to take another 10 seconds for ourselves. Tell me, what do we think we're going to need to do? Okay, so when I distribute, I have to multiply 5 times 2x. How many x's am I going to have here? 5 times 2 is, what, Isabella? 10x. And what's my constant going to be? 5 times 3. Avery?
15.
15. What kind of 15?
Positive.
A positive 15. Nice job, Avery. A positive 15. is equal to something. So what can we write on the other side of that equation so that it has no solutions? No solutions, remember, before we talk about that, what does no solutions mean? What does it look like? Avery, tell me one thing.
It has the same variables but not the same constant.
Same variables. And what did you say about the constants?
Not the same constant.
Different constants. Very good. Okay? So we have the same variable but different constants. Okay? So what was your thinking for the other half of that equation? I'm going to have a couple people share out their thoughts. First, let's take a look at Bridget's. Bridget said she chose 10x plus 3. What do we think about that? 10x plus 3. Does that work? Very good. We have the same variable, different constants. Billy, what was your idea?
Mine was 10x plus 3.
10x plus, what was it?
8.
8. We agree? Yes. Very good, Billy. Same variable, different constants. Last one, Avery, what were we thinking?
It said 10x plus 15 equals 10x minus 5.
10x minus 5. Good. I like that one. Our constant is a negative. Very good. It's different on each side. Good. Now, let's think back to Bridget's way of thinking. To get this left side on B simplified, I can rewrite this if we think about how we did it last time with Bridget's way of thinking. As opposed to Billy's perfectly perfect way of thinking, but we just can't do it with like this because we have to multiply by 7, but there's nothing there. So we have to break this into 2 parts. What would this look like if I were to break this into a division and a division? Billy?
7x divided by 7 and negative 21 divided by 7.
Boom! Billy, scary good. Yes. So, what would it condense, like how many x's would be left when I divide?
Just x.
Just an x. Yes, Billy, very good. X and 21, negative 21 divided by 7. Avery.
Negative 3.
Negative 3. So, what are we going to write on the other side of this equation so that it has infinitely many solutions? Nice job. Wait, let me see what Bridget's saying here. You're cut off. Give me 1 second. Yes, very good. Okay. So what would I write on the other side of this equation for it to have infinitely many solutions? What do we think? It's good, right? It's like a slow motion train. I don't know why I just jerked my head back. That was really crazy. Isabella, question first. Infinitely many solutions. If we're looking at an equation, what does it look like? Yes, it has the same variable and the same constant. So what did we write on the other side of this equation then, Annie? There's really only like 2 options. We could write it like 2 different ways, but it's the same thing anyways. What are we going to put? Just got really tired. So if we want it, we know that the left side, Annie, looks like x minus 3. And we want it to have infinitely many solutions. The other side has to look what?
Minus 3.
Well, something minus 3, what was it?
Minus 3.
If I wanted to solve for x, yes. But I'm trying to rewrite the other side of this equation so that when I look at it, it has infinitely many solutions. So infinitely many solutions, Isabella just helped us out. She said it has the same variable and the same constant on both sides. So what is my right side of my equation going to look like then? If the left side has an x, what's our variable going to be on our right side? An x, very good. If my variable on the left side, or my constant on the left side is a -3, what's my constant on the right side going to have to be? A -3, very good. Did that sort of make sense when we walked through it that one step? A little bit better? Good. Billy, what else did you think it could have been?
It also have been 21, -21,
Yeah, -21 minus, or plus 6, 7x?
yeah.
Yes.
This coming.
She's coming, I know, we're almost done. Let's think about this last bit. We could write it like that, Billy. We could also write it as -3 plus x. Okay, listen closely for your homework.
And,
No homework tonight.
oh God.
I tricked you. No homework tonight. You guys can turn
You're gonna
this.
fall through the floor one day with all the jumping you do in this class.
It's gonna be good. It really will be.
Legitimately almost ruined your punchline.
I know, right?
And you're like right on your